All right, hello, fellow electron microscopy aficionados. So I'm on a roll here with the videos. And so another one of these that I've been meaning to do for a while, we're going to talk about today. So you see, I am on the PFIB now. I'm off of the one of the STEMs. About to get the Themis back, which is exciting, but I am on the PFIB. And we are going to talk about today is how to prepare a cross-section face and then to high resolution SEM image the cross-section face. Okay. So the SEM columns on these dual beam instruments are very powerful. We have two of them, so on both of our dual beams, they're both capable of sub-nanometer resolution. The one on the PFIB, it also includes monochromation, which they call U mode, and that can actually push that resolution limit even less than that. So really some pretty impressive capabilities as far as the SEM imaging. So you'd be surprised what you can do with a good, SEM as far as imaging. Now, obviously, not going to be as detailed as what you would get with STEM, but sometimes you don't need STEM for what you're going to do. Okay, sometimes you can get by with just a good high-resolution SEM image, and of course, that is far less involved than making a lamella, right? And then pulling it out, and then putting it into the STEM, and then doing your STEM analysis. So anyways, we're going to talk about how to do this. This sample right here, okay, so push F5, okay, so this is our sample right here. This is a silicon wafer, and it's got a bunch of different layers in it, which is why I chose it. Okay, so I'm going to go ahead and hit beam on, and I'm going to drop this down, this voltage down to 2, and I'm going to up the current to 6.4. The reason I'm going to do that is one of the first steps we're going to do here is actually use some e-beam assisted platinum onto the wafer. So we got both our beams on here, and so I will select my e-beam quad and unpause. Before I do that, okay, you'll notice that my image area here, like with the nav cam, with the CCD quad, these are not taking up the full frame. This is a result of me using my video capture device. So normally this would encapsulate the whole area, okay? But it ends up looking like this, unfortunately, because of I guess it's screen pixel discrepancy or something like that, okay? But keep that in mind. Yours might look a little different, okay? But the essence is of course the same. All right, so unpause. Okay, so all right, so let me click on the sample here. Okay, turn down my contrast. I'm scroll wheel click and dragging upwards in the CCD quad. So I'm gonna get my sample at close to the 4mm marker, which again is eccentric position. We will mechanically set eccentric, of course. All right, that's good enough. All right, so now, okay, so we're starting to see some stuff here. Let me check something here. This is beam control. Okay, those are all off. What do we have here? Okay, do not degauss, and the scan rotation is 180. Okay, that's fine. All right, so let's come back over here, and now I need to find the spot that I want to take. Okay, so there's a couple spots in here where I already pulled. Yeah, so you can see right here. So I actually already pulled a couple lamellas from this sample. So that's one of them. and that's one of them over there. So if you look really closely, you can see here, it's a little hard to see, but there's a pad right here, and this pad is, from inside of that, we're going to extract our or prepare our cross section face, right? I already extracted a lamella from it, but I'm going to prepare the cross section face from inside here as well. Okay. All right. So just a few kind of quick things here. So when you're doing like live imaging, I do recommend you use just this lowest pixel resolution, and then you can drop this down. I like to use 300 nanoseconds here, just for moving around, especially when you have a beam current this high. Okay. All right. So let's mag in on the divot here. Use this as our reference. Get a decent focus. Hit the UFO button, otherwise known as link working distance with Z button. And then we'll come over to the stage or the navigation module and type in 4 millimeters. Okay. Now, if I was pulling this a lamella for doing STEM, I would be more careful about this. I suppose we can do it anyway, just for the sake of just showing you how to do it. But like if you look here, you can see I have these features. Okay, so these correspond, actually, it's a 001 silicon wafer. These correspond to 110 wafer directions. Okay, so if I was pulling a lamella, I would definitely want these perfectly level from left to right. So I can go ahead and do that anyway. It doesn't really matter, for doing high-res SEM, but so you can go to stage, align feature, and then you click and drag from, oops, let me mag out here. There we go. From left to right, it's only about a degree off. And then make sure you click stage rotation and horizontal. Okay, and there we go. All right. All right, so what I'm gonna do now is use this corner to mechanically set eccentric. So I'm gonna start at 0 and then tilt to 26 degrees. Okay, then move stage Z up because my feature went down. Now the stage on this PFIB is not super precise, okay? So you might be more fortunate. You might have one of the interferometer stages. This one's entirely mechanical, so its movements are not, super precise, but that's pretty good right there, all right? So initially, I'm just going to do one kind of quick and dirty setting right here. This doesn't have to be super precise at this point for this initial step. Okay, and then we're going to come over here to direct adjustments, and we're going to align our SEM. Okay, so adjust crossover zoom to change size of the crossover spot, adjust crossover tilt until the bright spot's in the middle. If you turn on your beam and you literally can't see anything, more than likely, when you go back over here to crossover, it's because this is like this, okay? If that is off center completely, you will not see anything, okay? So just an extra little tip there for you. All right, then down here, I'm gonna go to lens modulator. I like to set the amplitude somewhere around like, 0.3 to 0.4. And we're trying to minimize the shifting. So now this doesn't have to be super precise, at least initially, because, we're not in a high resolution mode right now anyway. We're going to use this mode just for, that looks pretty good right there. We're going to tweak this again, obviously, when we do the high resolution imaging. Okay, and then last thing, you can't see it, I'm adjusting the stigmator knobs on my knob set in front of me. Okay. Alternatively, you could come back over here to beam control and you could click and drag inside of Stigmator in here. Okay. I should also mention before I started, I made sure my beam shifts were zeroed out for both of my beams. If you click on each quad, okay, go to stage and you click beam shift reset. Do the same thing for the ion beam quad. Alternatively, have the quad activated. You come down here to the crosshairs. You can right click and click 0, and you can do the same thing there, okay? But you want to start with those zeroed out. All right, now you notice I have not done any ion beam exposure yet to my sample, and that is by design, okay? I'm trying to completely preserve the material stack, okay? So if I do any ion beam exposure at this point, I'm gonna risk, damaging it, okay? All right, so now, if you look closely here, you kind of see there's a little bit of a halo, and so I'm gonna move away from there. Now this does have a chromium coating on it, but even though it does, I'm gonna move away from that, and I am going to use this area to do my initial electron beam assisted PT dep, okay? So I'm going to take a snapshot, come over to patterning, okay, insert PTGIS, okay, let me turn off iSpy, we don't need that, and then I can draw a rectangle. Now you want to make sure your application is for doing e-beam deposition, okay. Now the dimensions of this, the stack of films on this is not very thick. I think it's less than half a micron, okay? So we don't need a very wide cross section here, okay? So I'm only gonna do, let's do 12 by 1.2 by, see it's saying it's gonna, let's do 3/4. I'll do 1.5 just for fun here, okay? Just so it gives us a little extra time to discuss something else. One other thing you can do here, if you wanna, you don't have to do this, but you can open up the flow initially, like that there, okay, and then you can make sure you take snapshots just to make sure your image is stable. It looks pretty good though, and then you start your patterning, okay? Now, because we're putting down the E-beam, once we have the E-beam down, we're good to go, okay? We can expose the surrounding area and not worry about compromising what's underneath the strap, okay? While this is going, so we've got about 3 minutes, I want to talk about the image acquisition parameters, okay? So now you have two right here on your toolbar, snapshot and photo, but you also have a bunch over here, okay, which I can't access now, but these are called scanning presets. So you have up to 6 of them that you can select over here as well. But let's just address right now the snapshot and the photo, okay? So if you go to Tools, Preferences, and then Scanning, okay, so right here, these are where you see the respective cameras. These are your settings for snapshot and photo. So if you look at the snapshot, you can see I have this set to the lowest pixel resolution and not the shortest dwell time, but it's only giving me about 1.2 seconds a frame, okay? Also, the bit depth is also really low. So the point of this obviously is quick and dirty image, okay, for the snapshot, okay? But if I look now at the photo, okay, so I've bumped up my resolution to the next highest setting. Now this will go really high, okay? I've never had a need to go higher than this 1536 by 1024, okay? But you could use these other two. This is kind of overkill in my opinion, so I bump it to the next, which quadruples my pixels, okay? But what I have this set to do, you'll notice the dwell time is only 1 microsecond. I have it set to do frame integration, okay? So right down here, right, I have dwell time, that's only 1 microsecond. So for one frame, that's really, really short. But what I'm having it do is I'm having it integrate 8 frames at 1 microsecond, Okay, that's going to give us roughly the equivalent signal of doing 1 frame at 8 microseconds. And then I also have drift correction checked. So as it integrates the frames, it is going to save or it's going to align the frames and account for any movement between them. Okay, so obviously I don't know why you wouldn't want to use this, right? So you could always keep that checked, right? And then I also have it here. I have it prompted to automatically ask to save when you do a photo. So now you can change this integrate to whatever you want. Okay, I have this set to only 8, but you could bump this up. I have another setting up here in the toolbar. Yeah, so I have another one up here, which I'll go over how to do this, which, let's see. So this one is actually for 20 integrations, okay? 1 microsecond, but 20 integrations. So anyways, so that's how you can set your snapshot and your photo, okay? All right, why don't we just, for the sake of, so that's going to be 1.6. I'll leave this alone. Okay, we'll leave it right there. All right, so let's admire our handiwork. I'm going to take out our PTGIS. All right, we got a good looking strap here. Okay, so what we got to do now, we got to put down some I-beam on top of this, okay? All right, so we're going to tilt to 26 degrees. Okay, still good, so I'm not going to tweak it. And then tilt to 52, so we're now normal to the ion beam, so that's perfect right there. Okay, so now your ion beam settings here. If you're using a PFIB, you want to set your voltage to 12 when you do ion beam depth, at least as far as doing like a strap. Okay, you don't want to use 30. Okay, you want to use 12 here. Okay, so I'm going to set that down to 12, and then we have to select the current based on our deposition size. Okay, so if you look down here, let's see, is this still on? Oh, my beam isn't on. What happened? I hit wake up. All right, let me do this here anyway. Okay, all right, so this is 13.6, so it's a little bit higher than this. Let me go to 0.1 nanoamps. Let's see what we get there. Okay, so this is a little bit better. All right, so let me go ahead and unpause this. Now, before I unpause it, I have mags coupled checked, so I'm going to see the same view field in both of these. Okay, now this isn't quite centered. What I'm doing here is I'm using beam shift. Okay, you could use the beam shift here, or you could use your knobs on your MUI. If you have that, I'm using the knobs. Okay, but you could also use. You can see the crosshairs moving here, right? All right, and then take a snapshot. We're going to again enter in the PT depth. Okay, but now you can see here. So now I have access to these scanning presets. So now, just very briefly to go over this. Okay, so these are scanning presets. So I have one here that's set for what I named it live E-beam, okay? And then the rest of these are higher pixel density and longer dwell time. And then these last two, these are frame integrated, okay? So if I click on this one, right, you can see what happens, right? It bumps up my pixel density and it increases my dwell time. So this is like, like a single pass for like a high resolution setting. Now, if I click S1 again, it goes back, okay? If I want to save one of these, what I have to do is hold down the control key and then push this, okay? So if I hold down the control key and push S1, okay, then it takes 1 frame, or it takes one, whatever this is, okay? So if I unpause it, so if I do S2, and I held down Control and then I pushed S2, you can see now this is blinking, right? Which means that when it gets to the end, it's going to stop, okay? Now I think I set this to also save as well, but we'll see here in a minute. Ah, yes, so that is set for autosave. All right, let me go ahead here, make a folder. All right, you always want to save as a 16-bit TIFF. Be careful about this overlay graphics because it will save like this plus if it's there. So I'm just going to call this PT strap 5000X. Data bar, you do want this checked because you keep this underneath it, okay? All right, there you go. All right, so now so now it's going back to this. If I click S1, so now S1, when I clicked Control, it didn't prompt me to save. The reason is I don't have it set for save as. Okay, so if I come over here, okay, and I mouse over this, okay, you can see, right, it says action none. If I go down to image acquisition, so if let me right click on this, okay, I can right click on S1 and click edit. Okay, so then we can see this, okay, so there's the name. You can call this whatever you want, okay, your resolution, your dwell time, your bit depth, the scan interlace and line integration, you don't really need to worry about. I really don't use averaging here. Some people like it, but I don't care for it particularly. And then again, right, if you're going to do frame integration, for doing the live image, you don't want to really do this. But then for action, I have none, right? So again, or you could say save or save as, okay? And then you can click apply. We didn't do anything, but I'm going to click apply anyway. So now if we right click on the second one, okay, so we can see this is, I have named high res e-beam single, meaning single pass 20-second dwell time, okay? That's exactly what we have here, right? So higher pixel density, longer dwell time, higher bit depth, and it's only doing one frame. That's what you have here when it says integrate. Now you can't do drift correction if you only have one frame, okay? It's not an option. Oh, you could tell it, but it's not going to do anything, okay? And then yes, I have this set for save as, okay? And then we can right click on S3. So this is high res, but this is drift corrected, frame integrated with a really short dwell time per frame. Okay, so I have this for only 300 nanoseconds a frame, but I'm integrating for 32 frames here. Okay. All right, so you have to add a lot of frames if you're going to do this. So I find sometimes if there's a lot of instability that this approach can work really well for getting a decent image otherwise, okay? Click apply, right click on S4, and this is the last one I have. So again, this is high res e-beam, but now this is DCFI 1 microsecond, okay? So 1 microsecond per frame, and now I have this set for 20 frames, and then to save as, okay? So the S4 setting is basically the same as the snapshot setting, except I'm integrating 20 frames instead of 8, okay? And of course, you could program 2 more settings here if you want. I haven't messed really with the S5 and S6 beyond what these were initially, so I only mess with these initial ones here, okay? All right. You also see these things that say mains lock. You don't really need to worry about this if your room environment is good. The idea behind this is that if you have like electrical noise in the image, you can kind of sync with it, and it can kind of reduce the effect of it. But again, if your room's okay, you don't really have to worry about this. Just as an aside. All right, so there we go. All right, let me unpause. Okay, now again, I clicked S4, so it's going to do a live scan as S4 here, okay? If I want to get rid of this, okay, I could go manually fudge everything here, or I could just push S1, okay? And then I'm back to 300 nanoseconds and the lowest pixel resolution, okay? All right, let me take a snapshot. Now, we got sidetracked here because we were about to do a deposition, and I wanted to show you all that. Let me take an image. All right, still looks good. Okay, so we're in the patterning page. Let's draw a rectangle. All right. So now we do PT dep I-beam, 12, 1.2, and let's do, we don't need a whole lot here. If we do 1, okay. So now, the key point here is the current density, okay? So I have 81 picometers into 12 by 1.2 micrometers, okay? So now if I pull up my handy dandy calculator here, okay, and I do 80 divided by 12 divided by 1.2, I end up with 5.5. That's so 5.5 picoamps per square micrometer, okay? And that is perfect, okay? So somewhere, you know, between, like, I would go as high as 10. I wouldn't go higher than that. So, you know, between 10 and 2 is usually a good number to use. I think they say between 10 and, or sorry, between 2 and 6 as the FEI recommendation. So this will work perfectly fine. Okay, but you don't want this number too high. Okay, if this number is too high, then you're going to end up milling the material away and not depositing. Okay, conversely, if the number is too low, you'll get deposition, but it's just going to be too slow. All right, let me open this up. Let me take a couple snapshots here just to make sure we're all stable. There we go. Again, strictly speaking, you don't really have to do that, and then we'll hit play here. All right, so while this is going, we can live E-beam image while the I-beam is doing its thing. You can unpause. I did F9 to do auto contrast and brightness, or else you can find the black and white cookie in your toolbar here and just click on that. That's the same thing, okay? The toolbar in this, you can auto arrange this, or not auto arrange. I mean, you can customize this. I have this customized actually with all the tools and where they are. So, you know, yours might look quite different, but you can actually customize this and put whatever controls you want or do not want in here, okay? Which is kind of neat. Okay, we don't really have a lot of noise in the picture, at least related to the ion beam, because we have a very high E-beam current relative to the I-beam current. So, but we can clean this up a little by going to, what's it going to say? This is the filter mode, okay? You want to click average. Okay, so now it's set to average 8 frames. You can come to here to number of frames and change this to whatever you want. If you click on integrate, what it does is it integrates 2 frames and then it stops, okay? This is not very useful for live imaging, okay? Sometimes this gets kind of stuck, like people will say, what's wrong, right? You know, I'm unpausing the image, it's, you know, and then really quickly it's like freezing again, okay? What's happening is this is stuck on integrate. So just put this back to live or put it to average and your problem should go away. Okay, so other things we can kind of chit chat here about before we get to the end result here, which is when we actually do the neat stuff, the high-res imaging. So to get a good high-resolution SEM image, okay, so the first thing you want is a small probe, okay? Your probe size is inversely related to your beam current, okay? So if I go to the current list here, as I go down the list, my probe is getting bigger down here compared to down here, okay? The reason you have these like single digit picoamp options, right, is because these are going to give you your smallest probes, okay? In terms of what I use for imaging, so when you're imaging a cross-section face, it's a little bit tricky because you don't really have like an optimal geometry for signal collection. So I usually will opt for this 25 picoamp setting. I usually won't go lower than this. If I was doing like a top-down image, I might drop to the 13 or even the 6.3, okay? Because the signal collection is just better. Obviously, it also depends on the materials. So if your materials generate a lot of signal, like if you're looking at gold particles on carbon, right? You know, that's right, just kind of shooting fish in a barrel, but you could get away with a lower current in that respect, okay? But you don't want to be like up here, okay? You don't want to be up here. You want to be down at the very most in the tens of picoamps, okay? So yeah, I would opt for the 25 picoamps as a default here. That works pretty well, okay? We're at a short working distance, right? We're at 4 millimeters. For doing a cross-section face, you really want to be at eccentric height just to make it easier for you. Now, if we were doing top-down imaging, we could shorten that a little bit more, but since we're imaging a cross-section face, as you can see right here in the CCD quad, we don't really have a lot of room here to move this up more, okay? We're looking at a potential collision hazard if we do that, okay? So we're basically constrained here to not getting closer to 4 millimeters. But I assure you, at 4 millimeters, we can get a really nice high resolution image, okay? And then the last part is your SEM mode, okay? So I'm not going to do this now, but we want to use mode 2 when we do this, which is immersion mode, okay? I kind of call this like high definition mode versus low definition mode, okay? Sometimes this is referred to as ultra high resolution versus high resolution, okay? So we will do that as well when we get close to doing that. All right, so not too bad. 7 minutes flying by here. And we are done. Platinum out. Okay, now again, I could put this back to live, or I could just come back to S1, okay, and then I recover my settings, okay? All right, so I am going to now, because I'm done doing depositions, I'm going to put my voltage back to 30, okay? And now I'm at 52 degrees, so I'm perfectly normal to the I-beam. Okay, what I'm going to do is I'm going to over tilt 5 degrees, okay? Now the way I have my scan rotation set, I have the scan rotation for the I-beam set to 180. So what that means is that when I cut a trench in the top, I'm going to see it in the bottom here in the SEM image, okay? So if you didn't want the 180 rotation, you could put it at 0, okay, and tilt to 57, and then you'd be cutting from the bottom, okay? It's entirely up to you. That's kind of a matter of kind of stylistic preference. All right, so let me go ahead here, unpause. Okay, I'm using my beam shifts to shift back, okay? So now you can't really see it, but the strap is now pitched downward just a little bit, okay? So basically, when we now cut a trench, so we're going to do regular cleaning cross-section, okay? And as was pointed out, well, let's change this application silicon, okay? So you could mess with the rotation here, or if you just do top to bottom, that also works. Again, the deep side of the trench is going to be the thick line here. I like to make this a little bit wider than the strap, so we'll do 16. Now, as far as the Y, so basically, the bigger you make the Y, the deeper into the cross section or into the sample you'll be able to see, okay? Now, we really don't have to go that deep here, okay? Because, as I said, I think pretty much all of the relevant layers are only like half a micron into the surface, okay? But for the sake of argument here, why don't we just make this bigger? We'll make it about like 7, okay? And then for the depth, I'm going to put 10 here, okay? Now, obviously, and then for the scan method, you want this on multi-scan. So there's 2 options here. The one you want to use is multi-scan. This produces a cleaner trench and a little bit faster, okay? Now, obviously, this is going to take 5.5 hours if we do it with this current, all right? So that's no good, right? So I'm going to change this to, let's see here. So I could do either 4 or 5 nanoamps. If I put it on 4, what do I get? Yeah, it's going to take a while. Okay, I'm going to put this on 15. Okay, and that's only going to take 3 minutes. Now, what I'm going to do here, I'm going to back this up way more, okay? My beam at 15 nanoamps is going to be much bigger. Now, the other thing you notice I didn't take any ion image here once I went up to 15 nanoamps, okay? I completely avoided that. This is a technique called blind milling. So basically what you're counting on is that your shifts between your images are reasonably well aligned, or shifts between current settings are reasonably well aligned, okay? But I am going to give this plenty of cushion here, right, between the trench and the strap, okay? But this is now only going to be about 3 minutes, okay? All right, so then we're going to go ahead and hit play. And we're going to come over here. Do auto contrast. So now you can see there's more noise here. And again, that's because we have a much higher ion beam current relative to what we did before. Okay, so this is again what's called multi-pass for doing a regular cross-section, okay? So basically it starts at the shallow end and it slowly snakes the beam closer to the deep side right here. And then once it gets to the deep side, you see here it says pass progress, it's going to go right back to the shallow end and do another pass. Okay, so the way this is set right now, this is going to go for 4 passes. Okay, that's usually the default. Okay, but this is perfect, right? We're getting right close to the strip edge. We're not actually digging into the strap. Okay, so you don't want to be digging into the strap at all at this point. Okay, so my positioning here was pretty accurate. Okay. Of course, the fact that I have over tilted by 5 degrees is also helpful here. That helps to make sure I don't eat too much into the strap. Again, I had this set to run 10 micrometers. Again, that was probably overkill, but that's okay. It's better to have a trench that's too deep than one that's not deep enough. Okay. And again, we can refine this, as we start to polish up the cut face. And there we go. All right, so now I'm going to reduce the over tilt by just 2 degrees to 55 degrees. Okay, and I'm going to drop to 10 picoamps here. So I'm going to continue with the blind milling. I'm going to use 10 picoamps for what I call the setup shot. All right, there we go. All right, so you can see like on the top, so this is all redep right here basically from the trench, okay? All right, now we're going to switch to cleaning cross section. Okay, again, I'm going to go 16. Again, I can go top to bottom. The thick line is again so this isn't deeper than this side. This is just the end side here. Okay, this is taking slices starting from the top. Okay, and yeah, reduce the Z to 5, so that should work okay. All right, so I'm going to put it right about here. I can't really see. Move this up just a little bit. Okay, and then I'm going to go to 4 nanoamps. Okay, let's come over here. So basically, all I'm trying to do at this point is I'm trying to remove material until I kind of see the redep on the strap kind of go away. And at that point, I'm going to drop my current down again, okay? We don't want to use this fib setting for the final polish. It's not going to produce the nicest result. We want to use a lower current for that. I keep my mouse on the stop button here. All right, so we're getting close here. Getting close. Done. Okay. All right. And I'm going to go down another degree to 54. Okay. I'm going to keep the cleaning cross section, but now I'm going to go down. I'm going to go to, I could use a nanoamp. Let's go ahead. Let's use a nanoamp here just to make this a little faster. Okay. Now at 1 nanoamp, I am going to actually get a snapshot at this point. I'm not going to blind mill. Okay. And what I like to do now is I like to, since this is what I'm going to use to do my final polish, I actually make the pattern a little bit skinnier than the strap is, and I make it well into the strap. Okay, so basically we're just gonna stop this when we get to a good point here, when we get a good looking cut face. Okay. Yep. So yep, that's all good. Take a snapshot here. Okay. And there we go. All right, so we'll come back here. Okay, so what am I looking for here? What I want to see is I want to be able to clearly see the E-beam platinum and then the I-beam platinum. Okay, so we're not seeing that just yet. Okay, there's still a little bit of redep here. I really can't make out where the E-beam is relative to the I-beam, so we're not deep enough into the strap yet, okay, to call this quits. Okay, so you can see every slice it does right there. The other thing I'm going to do is I'm going to pause the E-beam imaging for a few slices rather than continue the high current imaging, because I could end up with some contamination on the cut face, which I really don't want. But I'm not doing that yet because I haven't seen what I want to see just yet. All right, we're getting warmer though. Okay, so now we're starting to see it here. We're seeing the E-beam layer and then the I-beam layer. At least I thought I was. All right, where is it? Ah, there it is. Okay, so now you can see it a little bit better. Okay, there we go. Now it's coming in there. All right, so I'm going to let this run for maybe, I'm going to pause this. I'm going to let this run for maybe 3 more passes, and then I'm going to stop it. So there's one. Well, I'm going to do one more pass, and then I'm going to stop. Okay. All right, so now, at this point, before we do any SEM imaging, we want to change our SEM settings, okay? We don't want to start imaging it at this current because we could contaminate it, okay? So we're going to drop down to our intended current for doing the final imaging, okay, which I said was going to be 25 picoamps, okay? Now on this system has U mode. I have it set, where is it? Where is it? Okay, I have it set so it's on UC auto. What that basically means is that it's going to use U mode as long as the current is, I believe, less than or equal to 0.1 nanoamps, and the voltage is less than or equal to 5 kilovolts. Okay, so that means it's going to automatically use U mode. That's a good thing. Okay, so U mode is a way to remove or reduce the effect of chromatic aberration. Okay, so since we have that option on our microscope, we definitely want to make use of it. Okay, all right, so now we are ready to go. We can unpause this, okay, and then we're also going to now, as I mentioned before, we're going to switch into immersion mode. Okay, let me redo this. Now there's a little shift in the image. This is normal when you switch to immersion mode. There's a way to correct this, but it's usually never perfect. Okay, so I move with the stage, and now I'm using my focus knob to focus. Okay, all right. So come to direct adjustments, and now we have to realign everything. I have a big crossover spot here, so let me reduce this. Okay, so this is what the spot will look like with UC mode, okay? So again, same idea. You want to have this centered. You shouldn't have to worry about this last one. There's an alignment that you can run periodically that should take care of this. Just really quickly to show you, it's actually this. If you go to the alignments page, okay, and you go to, whoops, oh my goodness, it's actually going to do it. Well, why not? Let's go ahead and let it just do it, okay? So it's going to do auto U mode source centering here, so you can see how this works. Actually, not a bad idea to run this beforehand. It only takes like a minute or two anyway, so. Okay, so what it's going to do first is it's going to find I think I confused it. No, doesn't like this. Hold on. Yes, want to cancel execution. All right, let me try this again here. Okay, let me go ahead here. All right, let's do this under a little bit better circumstances. I'm going to move away from the strap here. All right, let me try this again. U mode source centering. Okay, I still don't like the way that spot looked. Okay, maybe this might have to do with the fact that I'm tilted. Oh, all right, I'm sorry. All right, we're gonna get it right, don't worry. All right, let me tilt back to 0 degrees. Probably doesn't like the fact that we're tilted here, so let's, all right, let's try it one more time. Okay, that's much better. Yep, there we go. There we go. All right, so now it's gonna run its alignment here. Normally it shows, will it show it on here? I don't think it's going to, probably because of the way I have the screen capture doing, the screen capture set up, but it shows it, you know, doing the alignment of the dispersed beam. So anyways, but now we know that we have this set perfectly when we go back and we want to use it now. All right, we're good to go now. All right, so where's our there we go. Okay, so now this is a little bit of an advantage here because we can actually, I mean, we can do, well, let's again check this here. So the crossover should be good because we just did this, okay, so that's fine. We still need to do lens alignment. I'm gonna tilt back to my original angle. So let's go to 52. Now, ideally, we'd want to image the cut face at 90 degrees, but obviously we can't do that. So we're a little bit hamstrung here. Okay, so I'm going to mag in on this side of the cut face. Okay, and then I'm going to go here, lens modulator. Okay, and now you can also make use of reduced area. Somehow this got set higher. Now, when you do lens alignment, you want to do this at a pretty high mag, okay? Again, this is, UHR mode, so. All right, what do we got here? Okay, that looks reasonable. All right, now I'm correcting astigmatism here. All right, let me try. Let's try this again. All right, still a little bit of movement here. Okay, that looks reasonable. All right. All right, so now we can see, right, the E-beam and the I-beam. So I'm actually going to mag in over here on the E-beam, and I am going to use this to really nail the stig. There we go. Okay, so I can actually see now the little grains here, okay, of the platinum. Okay, so these are perfect to help you focus and to stigmate. Okay. Yep, right there. Okay, there we go. All right, so all right, so now this is a pretty wide field of view here. I'm gonna go ahead and increase this. All right, so now other options here. If you go to navigation, you can turn on dynamic focus and tilt correction, okay? You wanna make sure you have this set to cross section now. That ensures that the focus is good from top to bottom, right? And your magnification or your scale bar is valid vertically and horizontally, okay? All right, let's see if we can't get a better focus here. There we go. Okay. All right. So let me come back here. And now we need to adjust our brightness and contrast. So I wouldn't rely on the black and white cookie here. I would rely on the histogram here. Okay. You want to make sure this is, entirely within the left to right bounds. Okay. You're not getting pile up on either side. That looks pretty good right there. And let's go ahead. I'm just going to do the photo here. And there we go. All right, so I'm going to rename this just 2500X here. All right, let me mag in a few clicks. Now you can also, for finer positioning here, you can use your shift knobs just to fine tune the positioning, okay? Especially if you have a less than precise stage like I do right now, okay? We can actually see like the granularity inside of the PT, which is great, okay? That means we have things dialed in really good. All right, that's 50,000. Okay, make a little bit of an adjustment. Now you want to be careful here using reduced area because you may end up causing some contamination to your material, okay, which you probably don't want, or to your area that you're using reduced area on. Okay, yeah, and we can see the grains right there. I mean, that's a nice image. All right, let me go up. Now I'm going to go up even higher here. That's probably the highest I can get and still keep like the whole stack in there. So I'm just going to leave that. One thing I can do though is I can shift the image left to right just using the X shift knob. Let me pull this up here. Okay, looks okay. Not really contaminating. So let me, all right, I'm going to do this S4. So this is 20 frames instead of 8. So there's actually like a super lattice structure in here, and we can actually resolve it pretty well, okay? This is an oxide, and this is an oxide right here. So these are, insulators, obviously, but, we can still work with them, not getting too bad of a charging effect. So are this in here. These are also oxides as well, so. Beautiful. Okay. All right, I'm going to use my X shift knob here, and I'm going to shift us over to a fresh area. Okay, so you can see the difference, right? This hasn't been exposed yet. And you want to strike quickly here. Actually, oh, no, I'm going to do S4. Okay. Now there's a limit to the shift, okay? You can see right here, I can't go forever. Where you see it says drift correcting because I have drift correction turned on. Again, why would you not want to use drift correction, right? Okay, there we go. All right, now if I mag in really close to this, I'm not sure I'm going to be able to get much better because these are all insulators. I mean, I can try it here just to see. Yeah, see that we're getting a little too much contamination there. All right, let me look here. Let me sweep back the other way here. Okay, these have been unadulterated. There we go. Now again, usually when you use your X shift, if your focus was good already, it should be okay as you shift across. You may need to tweak it, but again, we can see like we're seeing the granularity here. Whoops, sorry. I'm going to expand the image here so you can actually see this. Okay, so you can see the platinum grains here very readily, okay? So, I mean, the focus is good, right? All right. All right, let me do one more at 120 here. Now the astigmatism correction, this doesn't stay good forever, okay? So that's one thing you have to keep in mind. So, periodically, now again, you can rely on your PT here to help you, okay? You have to just kind of work quickly though. Yeah, so we're building up contamination, unfortunately, which is not uncommon at these crazy high mags that we're working. All right, let's see if we can't snag one more picture here. Okay, there we go. Yep. Okay. All right, a couple last things here I want to just go over really quick. So if we want to make some measurements here, we can do that, okay? So you can do this, I think, in patterning. No, we can't do it in patterning. You have to find the image processing panel here, okay? I do have toolbar shortcuts as well, but anyways, what you want to do here, so I'm just going to use line measurements, okay? If you click Control, that will constrain the line to be either horizontal or vertical, okay? And then you can click and drag for measurements. Now, because we have tilt correction enabled, okay, this number is valid without any additional correction needed, okay? What you will see here in the properties here is there's an option to apply cross-section correction, okay? We don't need to do that because we already applied it to the image, okay? So if we did, this would not be valid, okay? But what I can show you anyways, just for fun here, okay? Anyway, well, before I do that, okay, obviously you can mess with the color here, right? I like to use aqua actually. Stroke thickness, make that 2. Now to get rid of this plus, if you do Shift F5, that gets rid of that. You don't want to, burn that in, obviously. Can draw a few more measurements in here, right? So that stack of material is about 100. And this is a silicon dioxide. Yeah, so both about the same. There is a really thin chromium layer up here, okay? And we can kind of pick it out. So if we wanted to do that, what would that be? Yeah, that's about what I was expecting, something like about yay. All right, so now to save this, if you go to save as, you want to save this as 24-bit and then check with overlaid graphics, okay? That will maintain the color of the annotations. Again, you want to make sure you don't have the plus there or else that's going to get burned in, okay? All right. All right, so now again, these are all accurate. So now, what if I collect an image without tilt correction, okay? Let me turn off tilt correction here. Okay, so you see I don't have tilt correction anymore. Let me take an image. Okay, I'm gonna call no. And I'm gonna go back to 8-bit here for now. All right, so now what I need to do here, okay? Let me adjust all these. Now, one thing you can do, you can digitally zoom here, up here, to help make this a little easier for you. Oops. There we go. Okay. Reset zoom. All right. So now what we have to do is we have to apply cross-section correction here, okay? So if we do a cross-section correction, now let me start with the oxides because I know those should be about 360 nanometers thick, okay? And that's about what it's giving us, okay? You want to make sure that we're not pre-tilted, so that's 0, okay? And then for tilt type, you just want to have automatic, and then you should be okay. Okay, you don't have to worry about anything else. Again, assuming we're starting with, a flat sample, okay? And again, I can do this for the rest of these, right? So it's giving us about the same numbers we were getting before. This should give us about 100. Yeah, a little bit less, but close. Okay, again, I didn't quite measure them, probably the same, because again, with these, I did the digital zooming as well, so kind of makes sense that it wouldn't be quite the same. Okay, and then I'm going to save as. Annotations. Okay, so those are your options to do, thickness measurements, right? If you're so inclined. All right, what do we got here? All right, let me 0 the shift. What are we at here? Oh, we got plenty of real estate left. So it looks like right in here, this is still kind of unscathed. There we go. All right, let me take this guy here. Looks good. All right, so again, this is insulating, there's insulating materials in here, and yet, we can still get decent images from them, not really worrying a whole lot about charging. So again, the substrate is silicon, so that helps. All right, so that's 150. Okay, no tilt correction. Again, if you applied tilt correction, it is possible to find that out by opening these as like a Word, or not Word, like in Notepad. You can actually find out that metadata, okay? Okay, so that concludes how to do high resolution imaging of a cross-section face, or I should say in situ high resolution imaging of a cross-section face prepared inside of a dual FIB SEM, okay? And again, the whole time we had dynamic focus. There's really no reason why you wouldn't want to use this. This is just, great to have because it keeps your whole cross-section face in focus, all right? When we're done, let's turn it off. Okay, let me go back to preset 1. We will go back to field free mode. Okay, one other thing I should have mentioned. Let me go back to immersion to show you this really quick. Okay, if you come to the eyeball menu here, so when you're in immersion mode, you're using what's called the through lens detector, okay? There's two options here. There's what's called, this is not technically secondary, it's really secondary plus backscattered, okay? But they also have a backscattered only mode, which is genuinely backscattered. So when you're looking at these cross-section faces, generally speaking, I would opt for this first option, secondary plus backscatter, and not backscatter mode alone. The reason is that you just don't have a good geometry to get the backscattered electrons, right? Because we're imaging the cross-section face at an angle, okay? If we were imaging perfectly flat, then it would be a little bit more conducive, okay? But I mean, we can just, we can just experiment with it here just so we can kind of see. Now, if you switch to the backscatter detector, you're going to have to realign, or backscattered mode, I should say, you're going to have to realign everything, okay? The alignment is sensitive to how you configure your TLD. And plus, we also did a hop, skip, and a jump out of okay, there we go. There we go. All right, so why not? We can go ahead. Now, it might be a little hard for us to see the grains of the platinum here. Can we see them? Yeah, I'm not really sure. I mean, it's going to be harder to do this in BSE only mode, especially since we're, okay. Nice thing about BSE imaging though is it's less sensitive to surface contamination, okay? So if you're getting contamination buildup, you really don't have to worry about it to nearly the degree that you would in secondary plus backscattered. I know we can get better images than this. I don't have the STIG dialed in perfectly here. I need something to help with that here. So I can try using this. Okay, that actually looks better. Let's see what we get here. Really not too bad here. Okay, again, I don't think I have the STIG dialed in perfectly. It's much harder to do that with the BSE, especially since, again, we're only at 25 picoamps. So, you have to keep that in mind, right? That's going to be another factor here. 150, call that BSC. Do we have anything we can use here? Anything we can use? See, there's some stuff right here. Yeah, but I'm not sure. This is one of the challenges of doing immersion mode BSE. Again, because as I will again remind you, right, we are not imaging perpendicular. This might be a little more productive if we could do it that way, but we can't. Okay, this actually looks about as good as I would expect. All things considered. All right, so we're getting a little signal clipping here. Want to avoid that, obviously. Yep, so something about there. All right, so not too bad. Although again, right, to get the best resolution, I would stick with the secondary mode, okay? Or at least it's going to be easier to, dial in everything, right? So we can't really see the grains very well in BSE mode, so I'll leave that on secondary for the next person, so he or she doesn't get crazy thrown off. Turn off dynamic focus. Where are we? Why can't I see anything? Oh, okay. Yeah, so the crossover alignment, that can be affected by the mode too, okay? So when you swap back to field free, you might need to mess with that as well. Obviously, we'd have to mess with lens modulator again if we wanted to, do some more imaging, but I'm going to stop it there. All right, so that's the video on in-situ high-res SEM inside a dual beam. Please let me know if you have any questions or comments, and glad I'm on a roll with the videos, and looking forward to hearing from you guys soon. All right, take care.